Hello, this is Ben Ramp, and welcome to this presentation about enabling advanced user data migration and recovery scenarios with ConfigMgr operating system deployment. While the primary focus of this presentation will be about the integration of the Microsoft Deployment Toolkit with ConfigMgr, alternative options that do not require the use of MDT will also be reviewed and demonstrated. Because the scenarios that are the subject of this presentation are advanced, it makes sense to leverage MDT and the additional functionality it provides to implement customizations necessary to meet any extra requirements we have. I would like to note, however, that the concepts and examples presented here could be readily adapted for use with MDT when it's deployed independent of ConfigMgr, which is referred to as Light Touch or LTI to extend its capabilities. Furthermore, even if you're not interested in some of the more advanced techniques presented, I'm confident that you'll still find something to take away here that you'll find of value. We have a lot to cover, so let's go ahead and get started. The themes of topics we will be covering in this presentation are: first, we'll start with a review of the current state of support for user data migration and recovery scenarios provided by ConfigMgr OSD with and without MDT. Then we'll introduce some additional scenarios for which there presently is no built-in support. Next, we will look at possibilities for enabling new and enhancing existing scenarios for user data migration and recovery. This will include strategies for realizing these possibilities by reviewing a number of task sequences that implement customizations that provide support for these extended scenarios. It is during the review of these task sequences that we will also cover various tips, tricks, workarounds for known issues, and general explanation of the logic behind the OSD task sequences. From here on out in this presentation, I will use the term OSD to indicate the native functionality provided by ConfigMgr operating system deployment when used alone by itself. In other words, not using MDT integration or third-party toolkits, etc. I will use the term MDT to refer to the Microsoft Deployment Toolkit's zero-touch implementation and the additional functionality that MDT provides when integrated with ConfigMgr. As was introduced, the overall purpose of this presentation is to review and demonstrate options for enabling significant enhancements to ConfigMgr OSD functionality to support additional user state migration scenarios, which include running the User State Migration Tool 4.0 in its offline mode, which provides us the ability to easily resolve the number one cause of user state capture failures, that is, corrupted data structures on the disk. Now that we can run USMT in offline mode while in Windows PE where the local hard drive is not in use, we can run check disk with its /F or /R switches to correct any logical or physical problems with the disk prior to running scanstate.exe. Running USMT offline also has the added benefit of not having to worry about in-use files. While USMT 4.0 introduces the ability to leverage the Volume Shadow Copy service to migrate in-use files, this option cannot be used in conjunction with hardlink support. In addition to improving the reliability of migrating user data by being able to first check the integrity of the disk, running USMT offline also provides benefits in speed and convenience. Improvements in speed can be had for USMT migrations when performed offline using NTFS hardlinks. You may find at most it may only be a minute or two faster, but everything helps, right? I mention convenience because systems are often reimaged nowadays after the time spent troubleshooting problems with the system has exceeded the time it would take just to reimage it. It's quite convenient to be able to walk up to a system when it may be asleep, in hibernation, or even fully shut down, and be able to boot it from Pixie or Thumb Drive to reimage it with the user state fully captured and restored without first having to coordinate with the user a good time when they should stop using their computer and log off so that their user state can be captured without having to contend with in-use files, and then having to explain the distinction between logging off and shutting down so that the advertisement can run, etc. Also, by implementing offline USMT support, that means we can even reimage, while capturing the user state, a system that will not boot properly, or in cases where there's a problem with WMI, the ConfigMgr client, or other issues preventing the system from running an advertisement. In addition to offline USMT support, we will also cover performing automatic full system backups prior to any imaging activity using ImageX. Having this functionality can provide peace of mind while any kinks in the deployment process are worked out, or for sensitive machines where we may need to roll back the deployment to the previous image or restore files not captured by USMT rules. This is always nice to have for those mission critical systems like your boss's PC. Finally, we will look at how applications can be reinstalled based on a system's previous inventory above and beyond what is manually determined by a deployment engineer or programmatically by task sequence rules. Okay, let's go and begin our review of the current support for data migration and recovery scenarios provided by ConfigMgr OSD when used by itself, and then also when MDT integration is leveraged. So this chart is an attempt to condense a lot of information into a single slide, but I think you'll be able to follow along. First, some explanation as to what we're looking at here. Across the top of the table we have the three deployment scenarios, which are also sometimes referred to as deployment types. I will be using the word scenario and the phrase deployment type interchangeably. ConfigMgr and MDT also use different terminology to describe these scenarios, which are, first we have the new computer, which is what MDT refers to it as, / bare metal, which is what ConfigMgr calls it, scenario. This scenario describes the case where we have a computer that has a disk that has yet to be partitioned, or if it has, it will get repartitioned and all the data on the disk will be lost. Conventionally, this scenario involves no user data migration whatsoever because it is assumed that the computer is truly new or it is being repurposed. For the new computer scenario, the task sequence always starts in Windows PE. Then we have the refresh scenario, which is the MDT term. ConfigMgr sometimes refers to this scenario as the wipe and load or in-place scenario. This is not to be confused with the in-place upgrade phrase, which is sometimes used to describe the process of installing a new OS over an existing running OS where applications are left installed and all data remains intact. Instead, the scenario we're talking about here is where we capture the user state first with USMT, save it to an intermediate store like the state migration point, or keep it local in a safe area on the hard drive, reboot the computer into Windows PE, wipe the drive of all data except for that safe area where the user state store and task sequence data is kept, reinstall a new OS, all the applications, software updates, etc., and then restore the user state. The idea here is that the system has been completely reinstalled from scratch, but retains the user settings and data. This scenario does not permit repartitioning of the system disk, and the task sequence always starts in the full running existing instance of the OS. The third scenario is the replace / side-by-side scenario, where two task sequences are put to use. The first of these is usually a simple task sequence with its primary purpose being to capture the user state from the old system and store it remotely off disk to a state migration point. The second task sequence is often similar or even the very same task sequence that is used for the other two scenarios. That is, it deploys an OS to a separate new system, restoring the user state previously captured from the old system that ran the first task sequence. In ConfigMgr, before either of these task sequences are run, an association is made between the old and the new systems, which is used to link the user state between the two PCs. So those are the three primary OS deployment scenarios or deployment types. But as we progress through this presentation, I believe it'll become apparent that as Windows XP is fully phased out as an OS that is actively deployed, and its requirement for restoring the user state only with version 3.0 of USMT, there becomes less of a distinction between the new computer and the refresh scenarios because there is no longer the requirement for using only version 3.0 of USMT and its inability to capture the user state offline. This ultimately means that the decision to use either deployment type, new computer or refresh, becomes a purely operational and user experience 1 based on how the advertisement for the task sequence is initiated, and no longer bound to whether or not the user state can be captured because of a technical limitation of USMT. So with this in mind, along the left side of the table, we have the 3 client OSs that are commonly deployed in relation to the different transitions between OS versions as user state migration is concerned. The second column in from the left denotes the deployment method, not to be confused with the deployment type. The first deployment method we have is OSD when used by itself in orange. Then OSD when used in conjunction with MDT integration in blue, and then in green what we can do with a custom deployment method to support additional requirements, which may or may not include MDT and our own scripts and tools or those by other third-party integrations. As you'll note at the bottom of this table, a legend denotes the meaning behind each graphic. Further explanation for each will be provided as we discuss the current state of support for user data migration for each OS version transition and OS deployment method. The different classifications of functionality that are reviewed here in this table are a reflection of the default task sequence templates that each product provides, OSD and MDT. Okay. So let's quickly work our way through this table, row by row, from left to right, starting with what OSD provides natively for each deployment type, beginning with Windows XP deployments. I should mention at this point that for the purposes of this presentation, any reference to Windows XP assumes that we are deploying the 32-bit version of Windows XP. The unique deployment requirements for the 64-bit version of XP are not addressed in this presentation. With that said, during the new computer scenario, by default, OSD assumes that the disk is unpartitioned or contains no data and provides no built-in functionality for capturing any user data prior to partitioning and formatting the disk. So we have no support for any migration of user data indicated for this scenario. For the XP to XP refresh scenario, OSD does have support for capturing and restoring user data and settings with the user state migration tool of version 3.0. We must use version 3.0 of USMT because we cannot use the latest version, version 4.0, to restore a user state to an XP system. We also cannot restore a user state that was captured with version 3.0 of USMT with USMT version 4.0 and vice versa. So here we have the yellow light bulb to indicate that we are using USMT version 3.0, and it has the requirement that the user state be captured in the full running OS. In other words, it has no offline capture support. Then we have the replace scenario for XP that involves the capture of the user state from the old XP system, again with USMT version 3.0, and another task sequence that essentially runs the same task sequence steps, or the very same task sequence, as that used for the new computer scenario that runs an OS deployment on the new computer that restores the user state on this new system that was previously captured from the old system. Again, because we are migrating from XP to XP and require the use of USMT version 3.0, which has the limitation of not being capable of capturing a user state offline, we also have the yellow light bulb to indicate as much. In fact, user state migrations for the replace scenario must always be performed online, regardless of which version of USMT we are using, because the replace scenario always involves a state migration point to copy the user state to and to restore it from. The way in which OSD determines where the user state is stored is by executing the request state store action, which has a built-in condition that prevents it from running in Windows PE and can only be run in a full OS. This means that the first task sequence used in the replace scenario must always be run on the old system through an advertisement while the full OS is running. For the new computer, USMT's load state, which restores the user state, cannot ever be executed offline, regardless of version. It's only USMT 4.0's scan state, which captures the user state, that can be run offline in some scenarios, but again, not for the replace scenario, because the user state must be copied to a state migration point And the only way we can get a handle to the state migration point is with the request state store action that cannot be run in Windows PE, only in a full OS. Now, shifting down a row and looking at what is possible when deploying XP with MDT integration is added to the equation, again we have the new computer scenario. Here we have the picture of a package to represent the functionality that MDT provides for a means of querying the ConfigMgr database for a list of packages to install based on the inventory from the ConfigMgr client previously installed on that same system. These packages would be above and beyond what a deployment engineer might manually select from a front-end HTA or those that would get automatically installed based on task sequence rules. The list of packages to reinstall is built by executing a stored procedure that performs a lookup for any applications previously installed on the system based on the add remove programs list from inventory associated with the MAC address of that system. If any records for add remove programs from inventory are found for the system, they are then matched against another custom table that is manually set up and maintained that determines which of the previously installed applications should be reinstalled, and if so, if they should be replaced by a newer version of the same application. Because we have complete control over which applications are automatically reinstalled based on inventory, there shouldn't be any concern about applications getting reinstalled that shouldn't for licensing or other reasons. I find that this is extremely useful for packages that might otherwise be missed in a deployment because their installation is managed based on exception. For example, there is always a handful of systems that might need something like an HR application that only a few individuals know about what systems should have it installed. With this functionality, which is optional, if an application was ever installed on a system, it will always get reinstalled. So it's a way of enforcing application installations. Another example that might help to illustrate the usefulness of this feature is the case where we need to tag a system as mission critical or otherwise indicate that it requires special handling. This tag might be a manual process that exists as a file on the hard drive or a custom registry key that is inventoried by ConfigMgr. To prevent the accidental oversight of forgetting to retag the system during a reimage, you can have that performed automatically. We'll review and demonstrate this functionality later on in this presentation. Now shifting over with the refresh scenario, MDT again offers the functionality to restore previously installed apps, but it also can optionally perform a full system backup to a WIM image prior to wiping the disk, which is represented by the pie-shaped cylindrical hard drive object. The backup can be configured to include all disks and partitions in the system, not just the C drive, which is the default. This option can be extremely useful and provide peace of mind when you are piloting a new image, task sequence, or USMT rules before they've been fully tested and debugged, or when deploying to mission-critical systems, or other sensitive systems like your CEO's PC, where no data can be lost or otherwise anything go wrong. Since the name of the file to which the backup is stored is based on rules you define, the WIM image archive that is created for a system can be appended to any existing backup image for that same system, which means one WIM file using single instance storage could be maintained for all reimages of the same computer, within reason of course. While not covered in this presentation, this functionality could even be rather easily extended with some lightweight scripting to provide automatic image rollback if so required. Again, moving over, we then have the replace computer scenario in which, with respect to user state migration, MDT also provides the option for backing up the old system before it zeroes out its disk. But because it only provides this option for the old computer and not the new computer, which is not always new per se, but sometimes a repurposed system that may have data on its disk that we wish to recover at some point, we have only the half pie in this box to indicate as much. Now, shifting down 2 rows and looking at what is possible when migrating from Windows XP, Windows Vista, or Windows 7 to either Windows Vista or Windows 7, with the functionality natively provided by OSD, our options are identical to those when migrating from Windows XP to Windows XP, which is the first scenario we reviewed and depicted in the first row of this table. However, when we add MDT to the picture for the new computer scenario, MDT again gives us the ability to restore applications. but also the ability to capture the user state, if there is one, offline using the user state migration tool version 4.0. We have the half yellow, half white light bulb in this box to indicate that there are some configurations and scenarios that MDT affords us the ability to capture the user state offline. Yet for many common configurations and scenarios, it still only provides for online user state capture functionality. Offline user state capture with MDT is only supported by MDT's user-driven installation, often abbreviated as UDI mode, and only when deploying Windows 7. If you are using MDT but not UDI, or if you are migrating to Windows Vista, then capturing the user state online is the only option. Don't get me wrong, I think UDI is great, but there are some deployment scenarios in which UDI is not ideal. It's really designed around the concept of end-user interaction and participation in the deployment process, which is not always desirable. For example, think of the case where we want to upgrade a mass of machines overnight. And again, UDI only supports the deployment of Windows 7, and so there are plenty of reasons for, in scenarios where extending offline user state migration beyond those provided by UDI makes sense. And as I mentioned before, what we cover here in this presentation in terms of extended user data migration options can be carried over to MDT Light Touch as well, where UDI does not even exist. I'd like to clarify here at this point that when I use the term online with respect to user state migration, that does not mean to say that we still cannot use USMT 4.0's hard link support. What we mean by offline is that USMT can be run from within Windows PE, which gives us the ability to recover the user state from systems that are not bootable, and also not have to contend with in-use files while still leveraging NTFS hard link support for speed. Moving on, for the refresh scenario, MDT again gives us the ability to reinstall apps, perform a full system backup prior to reimaging, and perform offline user state capture with UDI only, and only when upgrading to Windows 7. Otherwise, it's online state capture, so again, we have the multicolored light bulb. For the replace scenario, again, our options remain unchanged from those when deploying Windows XP with MDT. So, those are the data migration capabilities supported by OSD and MDT for each OS version transition and deployment type. Finally, after having reviewed what OSD and MDT can and can't do and when, taking what we've just learned, let's now look at what we can do with a little creativity and a desire to extend the best of these capabilities to more scenarios, thus giving us more data migration options. What I'm talking about here is a custom deployment method. With a custom deployment method, using OSD as our foundation, and which may or may not include MDT or other third-party extensions, let's now quickly review what I will be demonstrating later in this presentation is possible with regards to bringing more options for user data migration to more scenarios. Let's start with what we can do to improve our capabilities when deploying Windows XP. Again, it's important to reemphasize here that we are against some hard support limits of the user state migration tool version 3.0 and its inability to capture a user state offline. Yet it is the only version of USMT that is supported to restore a user state to an XP system, so it is the version of USMT that we have to use. So for the Windows XP new computer scenario, with a custom deployment method, in addition to MDT's ability to reinstall previously installed applications, we are also going to be looking at ways to perform a full system backup prior to any reimaging activity. For the refresh scenario with XP, we will just be taking what MDT provides as is. There's not much we can do to build above and beyond what MDT is already doing, but we will be reviewing ways of emulating this functionality without the use of MDT should you choose to go without it. Moving over to the replace scenario, in addition to what MDT provides, I will be demonstrating how to extend MDT's auto application reinstallation functionality so that it can now be used with the replace scenario, so that a managed set of applications associated with the old computer's inventory can now be reinstalled automatically on the new computer. Shifting down to the last row of the table, you'll see that there's a lot more we can do now that we are transitioning from an older to a newer version of the operating system, because we can take advantage of USMT 4.0 and its offline migration support. For the new computer scenario, again, in addition to what MDT provides with regards to system backups and reinstalling applications, as indicated by the fully white light bulb in this box, I will be demonstrating that any user state found on a system can always be captured offline prior to reimaging, as long as the OS being deployed is not Windows XP. Again, it's okay if the system from which we're capturing the user state offline was running XP. So we're going to be looking at enabling this advantage regardless of whether or not UDI has been implemented or if using MDT at all. As was related before, the primary use case here is the ability to recover the user state from a system that is unable to fully boot or has problems with its ConfigMgr client or other issues preventing it from running an advertisement for the OSD task sequence for the refresh scenario. For the refresh scenario, we can also take what MDT provides and build on that so that we can also always utilize User State Migration Tool 4.0 and its offline state capture capability. And finally, for the replace scenario, we will be carrying over the same options that we'll be enabling for the replace scenario when deploying XP. That is, full system backups for both the old computer and the new/repurposed computer, if desired, and auto application reinstallation. Before we begin addressing our task sequence strategy for putting into practice our user data migration customizations, I believe it is worthwhile at this point to quickly review what I consider to be some of the key benefits the Microsoft Deployment Toolkit integration with ConfigMgr provides above and beyond what is native to OSD. It is my opinion that MDT makes operating system deployment with ConfigMgr a little more approachable and easier for the beginner to get up and running with a fair amount of sophistication rather quickly. That's right, I said it. MDT makes OSD easier. I have routinely found that if I can get someone past the intimidation factor, I am ultimately able to convince them that they need not know everything there is about MDT to gain from it. Simply using the default task sequence templates and the accompanying scripts that MDT provides, most customers will be much further ahead in their OS deployment capabilities than if they had chosen not to use MDT. Yet at the same time, MDT opens up some more advanced capabilities for those that do have experience and expertise with deploying operating systems, particularly with ConfigMgr. With all that said, in no particular order, the first nicety that MDT provides is the Create Microsoft Deployment Task Sequence wizard that is invoked from the Task Sequences node in the ConfigMgr console. This wizard will walk a beginner through establishing all the assets required to deploy an operating system end-to-end, including the creation of the boot images and packages for the ConfigMgr client, USMT, MDT files and settings, and the operating system source files. The end result of this wizard is a task sequence that can be used to support all three deployment scenarios, whereas this is not the case for the default task sequence templates provided by ConfigMgr. As I just related, the task sequence templates provided by MDT are all-encompassing in terms of the deployment scenarios they support. What's also nice about them is that they break out the task sequences into the main deployment phases, those being state capture, pre-install, install, post-install, and state restore. Having these phases clearly defined in the task sequence as groups not only facilitates learning, but makes adding any custom actions to the task sequence much more intuitive and helps take the guesswork out of where it would be most appropriate to add new steps. For example, all too often I'll find customers who have added an install software action while the task sequence is still running in Windows PE and then wonder why it's failing. Having some knowledge about the different deployment phases and using the MDT task sequence templates should give you confidence about when and where in the task sequence any custom action should be added. MDT also adds an extended list of task sequence actions, particularly for servers. It provides built-in support for installing Active Directory domain services, DNS, DHCP, and many other roles and features. One of my favorite features of MDT is it makes applying updates offline for Windows Vista, Windows 7, Server 2008, and R2 very simple. Patching an OS offline has a number of advantages. For one, the operating system being deployed is never exposed to the network unpatched and vulnerable. Another is that updates applied offline usually complete much faster than they would online when there's other activity occurring on the system. While OSD has a number of variables it provides out of box that can be evaluated and set during the execution of a task sequence, MDT adds many more variables for commonly sought after attributes useful for controlling and parameterizing the actions performed by the task sequence. For example, MDT has built-in variables that can be evaluated to determine if a system is a laptop, desktop, or a server. Instead of having to write a WMI query for this information, MDT does this for us and creates these variables with its ZTI gather script. The full list of these variables, or properties as MDT refers to them as, are documented in the toolkit reference included with MDT. A file called CustomSettingsINI can be used to set variable values, and even for some basic logic constructs for variable evaluation. Using CustomSettingsINI can be strategic when you have a common set of variables and logic that you want to share between multiple task sequences. The MDT database usually comes into play when you have a lot of settings that are specific to locations, user roles, or individual systems that you want to persist indefinitely between reimages. I already mentioned, and will be demonstrating shortly, how to enhance the functionality where MDT can perform a full system backup prior to reimaging and reinstall a managed set of applications based on the inventory from the ConfigMgr client previously installed on the system. Another feature that MDT brings is the ability to capture the members of local user groups during a refresh of a computer and restore them after the new operating system has been installed. This can be especially useful for server deployment scenarios. Tattooing is the process where MDT creates a registry key and populates it with details about the deployment, which include the time it occurred, the deployment method, deployment type, advertisement ID, and package ID. MDT can also take logs relevant to the deployment of a system and copy them to a central server for review. This can be a real time-saving convenience when you need to troubleshoot issues. By default, OSD will always attempt to copy the user state to a state migration point, which is usually not ideal during a refresh scenario where we are capturing the user state from and restoring it to the same system. With MDT's ZTI user state script, it will determine automatically if there's enough space on the hard disk of the system being reimaged and keep the user state local in the task sequence data folder that is safe from being wiped. This feature not only can save on network utilization during the deployment process, but can significantly reduce the amount of time it takes because the user state need not be copied back and forth from the state migration point. Furthermore, when using USMT version 4, MDT will automatically enable NTFS hard link support, which dramatically reduces the time it takes to capture the user state because it doesn't need to make a copy of files, and it only requires 250 megabytes of free disk space, thus increasing the probability that the user state can stay local. A new feature of USMT version 4 is the introduction of the mygdocs.xml default migration rule file. mygdocs.xml uses a new helper function that enables it to dynamically migrate files that are registered as a document type. I use the term document loosely here because an example of a document for the purposes of this discussion may be an ISO file. Let's say, for example, I have a bunch of ISO files in a folder off the root of my C drive. If these ISO files are associated as a document type with an application like Roxio, for example, then mygdocs.xml can detect this by reading the registry and automatically migrate these ISO files, even though there's no explicit migration rule defined to do so. Now, if I were to uninstall Roxio from my system prior to capturing the user state, thus resulting in ISO files no longer being associated with any application, then mygdocs.xml would not migrate these ISO files from my system, unless I had a custom migration rule defined up front. So, mygdocs.xml, which is optional and only available in USMT version 4, can help with the nearly impossible task of having to account for all the file types and where they may exist on a system that your user community cares about, defined up front in custom migration rules. What MDT does that's nice is it emulates this functionality and makes it available to USMT version 3 with its ZTI AppGen XML script. Okay, let's review our task sequence strategy for implementing all of this extended user data migration functionality. Our strategy starts with two types of task sequences. The first type is used for deploying our operating systems and is utilized by all three deployment scenarios. If, as mentioned previously, our task sequences are based off of the client task sequence template provided by MDT, then support for all three deployment scenarios is automatic within a single task sequence. The second type, which is used solely as the first half of the replace computer scenario, exists primarily to capture the user state from the old system and copy it to a state migration point. One of my goals is to always try to minimize the number of objects, like collections, packages, configuration files, task sequences, etc., that have to be managed and maintained. With that principle in mind, we have the fewest number of task sequences possible to support all three operating system deployments for each of the three deployment scenarios, while keeping the task sequences as simple and straightforward as can be and without compromising the technical integrity or robustness of the product. Referring back now to our first type of task sequence, again, that which is used to deploy Windows, to support everything we reviewed thus far for all three versions of Windows, we need three different task sequences, one for each OS. The primary reason we need all three task sequences is that there are differences in how the user state migration tool is implemented based on the version of Windows that a system is being migrated to. User state migration considerations aside, while we could have only a single task sequence that conditionally installs each OS based on a variable value that determines which OS to install, the problem with this approach is that if the task sequence was ever deployed via multicast, all package content, including the source files for all three operating systems, referenced in the task sequence, would be downloaded to the system's hard drive prior to executing the task sequence. This would obviously have a huge cost to the network and to the deployment time, so for this reason and others, we have each OS with its own task sequence. For Windows XP, we always have to use the user state migration tool version 3.0 for both the state capture and the state restore, which must be performed online while in the full Windows XP operating system. Using the target XP switch optimizes the scan state process and captures additional system settings that are specific to Windows XP. So ideally, we should be using this switch to minimize the amount of work scan state has to do and the time it takes to do it, while not risking something not getting captured that should. USMT version 3 also uses different default migration rule XML files. Specifically, it uses migsys.xml, while version 4.0 does not. Finally, because it is not supported to edit the default migration rules, the way to customize the default migration set defined by these default migration rule files is to generate a configuration file, which is typically named config.xml. So each Windows version is going to have a unique migration configuration file if we choose to generate one. For Windows Vista, although we can use USMT version 4 and its ability to capture the user state offline, because again, ideally we don't want scan state to overlook Vista-specific system settings during its capture, we are going to want to specify the target Vista switch. The target Vista switch can only be used if scanstate.exe determines that it is running on a Windows Vista system. Since our Windows PE images are based on Windows 7, we cannot run scanstate offline while in Windows PE with the target Vista switch. So this is why we are capturing the user state online if possible. If not possible, for example the system won't boot, then we can capture the user state offline and get what we can. It's just that we risk not capturing some Vista-specific system settings. USMT version 4 also no longer uses migsys.xml as a default migration rule file, and instead introduces migdocs.xml as a new default migration rule file. So, between version 3 and version 4 of USMT, both provide migapp.xml and miguser.xml, while MyGsys.xml is unique to version 3 and MyGdocs.xml is only for version 4. If we choose to include all the default migration rule files during our user migrations, then with version 4.0, we really have a choice between MyGdocs.xml and MyUser.xml. We don't want to specify both, otherwise it is likely that files will be migrated twice during state capture and duplicated on the disk during state restore. Generally, MyGdocs.xml is preferable to MyUser.xml because it includes the same default user profile structures as MyUser.xml. Plus, it'll migrate document file types dynamically based on the applications installed on the system during state capture that may exist outside of the standard user profile folders. When deploying Windows 7, we can always capture the user state offline, and scan state by default is optimized for use with Windows 7, so there are no special considerations or caveats. Now, looking at our task sequences that are used by the first half of the replace/side-by-side scenario, whose primary purpose is to capture the user state from the old computer, the reasons we have the 3 task sequences again are to account for the differences in how USMT should be run. For this scenario, USMT always runs online in the full OS. Again, we have the Windows version-specific targeting switches and differences in default migration rule and configuration file use. Something that we'll touch upon only briefly is that for Windows 7, with the P2V Migration for Software Assurance Solution Accelerator, we can automatically create a VHD of the old computer and restore it to the new computer. Before we transition into exploring the actual task sequences and the techniques for implementing the user data migration enhancements in detail, there's one last topic that's worth reviewing as it pertains to overall strategy. With so many different places made available for defining and setting values for task sequence variables, it can be somewhat confusing sometimes determining where best to. Well, there's not necessarily any right or wrong place to define variables. There are strategic characteristics for each. MDT's custom settings INI, by default, is shared by all task sequences based off the MDT task sequence templates. This file is a configuration file used by MDT that is often customized to construct basic rules to control deployments. Custom settings INI can be used to set the value for existing variables or to define custom variables. Because it is shared by all MDT task sequences, this makes it the ideal place to define common deployment logic or to set variables that should apply to all operating system deployments. Should the deployment rules in custom settings INI become too complex and unwieldy to manage and maintain in a single INI file, among other reasons, custom settings INI can be configured to interface with a database to get deployment rules and variable values. So, my general philosophy is that for any deployment settings that are not operating system or deployment scenario specific, likely to stay constant for all deployments, and that I want to make applicable globally to all task sequences, I will put those into custom settings INI or the MDT Deployment Workbench database. For settings that are dependent on the version of Windows that I'm deploying, I'll define those within the task sequence that is specific to that operating system. If any logic becomes too complex for what is possible with what the task sequence engine provides natively, or if I want to keep my task sequence steps to a minimum, then I'll sometimes create a simple VB script that is executed by a single task sequence step that includes all this extended logic. If I'm not using MDT, then I'll use computer or collection variables for settings that I might otherwise define in MDT's custom settings INI. Or when I need to schedule a fully unattended mass refresh of machines and set variables that might normally be manually set using a front-end HTA. But even if I am using MDT, I sometimes find setting variables on collections in particular valuable when I want to make any per-deployment customizations that would not otherwise be defined in custom settings INI, or where I want to leverage ConfigMgr client discovery or inventory data from systems to customize the deployment. This typically comes into play for the refresh scenario when I need to perform a mass OS deployment to many systems completely unattended. but also could be put to use for the replace scenario as well. For ad hoc deployments that are performed interactively, where I may want to specify one-off deployment settings or override variables set elsewhere, this is when I'll set these variables using a custom front end or UDI, which is normally only used during the new computer scenario, or potentially on the quote-unquote new system during the replace scenario. Any front-end means for a deployment engineer to interact with the deployment is usually implemented with the OSD pre-execution hook in the boot image, which is automatically suppressed during the refresh scenario. I will be demonstrating next how I leverage all four locations for defining deployment rules and task sequence variables to support the deployment of Windows XP, Windows Vista, and Windows 7 for the new computer, refresh, and replace scenarios using the 6 task sequences we reviewed previously. But before we do proceed, I again would like to reiterate that while I will be demonstrating techniques to enable additional user data migration options that do not require MDT, the emphasis will be on how MDT can be leveraged to facilitate these customizations. In examples where MDT is used, everything is accomplished by controlling the behavior of default task sequence actions and/or MDT scripts, not by modifying even a single MDT script. As you will soon see, while some of the customizations could be implemented with simple scripts that do not require MDT, using MDT will ultimately mean a lot less work given that MDT has robust error handling and reporting built in and will safely halt the deployment should anything go wrong. I'd like to note here that during our review of task sequences that I'm going to be primarily focusing on and discussing only the changes made to the task sequence templates to support our customizations and not on the default actions included by the templates. I will be providing each of these task sequences and all supporting scripts along with this presentation. Okay, so without further ado, let's first start by reviewing a resource that will be common to all of our deployments, Custom Settings INI. This is the sample Custom Settings INI that will be referenced by all task sequence examples used in this presentation. My intent by showing this file is not to explain how MDT processes it. That is beyond the scope of this presentation. In fact, I will assume that you have at least a basic understanding of how to create deployment rules with Custom Settings INI. If not, then the idea is that we are using it to set task sequence variables, or properties as MDT calls them, that will be shared by all task sequences. The default section of Custom Settings INI sets variables applicable to all deployments, so in this section, please note the following. I have a base set of command switches specified for scan state and load state. I say base set because, as we considered earlier, we'll want to include additional variables that are specific to the deployment scenario and the version of Windows being installed. USMT deployment scenario and Windows version specific switches will be appended to these USMT related variables in Custom Settings INI in the task sequences. For scan state, which captures the user state, I have specified that I want to exclude all local accounts and only include domain accounts, but only if the domain user has logged on to the system in the last year and a half, and to overwrite any existing state store. Since load state can only restore what's first been captured by scan state, there really is no need for me to include any switches here, but I could, for example, have scan state capture the state for both local and domain user accounts, and then limit what is actually restored by specifying appropriate load state switches. This next set of variables is used by MDT for specifying which drives should be captured during a system backup, and the location, folder name, and file name for the WIM archive. The next sections I want to call out here are location and location settings. These sections reference the MDT database, so we can't see by reviewing this file what configuration and settings are associated with them. For that, we have to take a look at the MDT Deployment Workbench database. While we could use SQL tools to view and modify the MDT database, MDT's Deployment Workbench does provide a friendly user interface for managing it. To do that, I need to open MDT's Deployment Workbench MMC, as shown here. Once open, expanding the Advanced Configuration node, then Database, I see that there are 4 different types of rule settings I can define. Those for individual computers by MAC address, user roles, the location of the computer at the time of deployment, and the make and model of computers. What I wanted to show here is that I've created a location. If I double click to review the properties of it, I can see that there's a single network associated with it. If I click the Details tab, I can specify deployment settings that are applicable to all systems that have one or more default gateways associated with this location at the time of running a task sequence. You can see that I've specified the SL share to which deployment logs can be copied for troubleshooting, and the backup share variable which, together with other backup variables included in custom settings INI, provides MDT all the details it needs to perform a full system backup of the computer to the specified path, in which the path is specific to the default gateway of the system at the time of its deployment. So that was a quick review of the variables that relate to user data migration functionality that are set by custom settings INI and which apply to all deployments and for all scenarios. The next thing I'd like to review briefly are variables that I'm also setting with the front-end HTA, which is used primarily for the new computer scenario, but could also be put to use for the replace scenario, but never for the refresh scenario. So here's the front end that I'm executing with the OSD pre-execution hook in my boot images. Now I've already recorded a separate presentation about how to implement such a front end, so I will not be going into any details here. However, please note these 2 options. Also, please note that I'm prompting for location in this HTA. You might be asking why I'm prompting for this, since I can already automatically determine the location of the machine using rules in custom settings INI. While this is true, the location settings defined in custom settings INI are only valid for the location of the computer at its time of deployment, which may not necessarily be its final resting place. For example, many customers will have a designated build site where they build the majority of their systems, which are then later shipped out to remote locations. So with this location prompt in the HTA, I'm using it to set a variable, which I might also set on collections or computers in the ConfigMgr console for the refresh scenario, to drive deployment rules that are specific to the location of the user. If we take a quick peek behind the code of this HTA, I want to show you the variables that I'm setting based on whether or not either of those 2 checkboxes are checked. I'm defining and setting the value for a custom variable called offline state capture if the option to perform offline state capture is checked, and another custom variable called do backup if the option to create a backup image is checked. These variables will be evaluated in our task sequences. So I think we're now ready to start reviewing our task sequences in detail. We'll start with the task sequence that we will use for the deployment of Windows 7 that supports all 3 deployment scenarios. What we are looking at here is the task sequence that we are using to deploy Windows 7. As we covered previously, we are actually using 2 types of task sequences. One that deploys Windows, and one that is used primarily to capture the user state from the old computer for the replace scenario. We'll use our Windows 7 specific task sequences as our reference examples and examine them more comprehensively. And when it comes to reviewing our other task sequences that are used for Windows XP or Vista, we'll just point out the main areas where they differ. This task sequence, like all task sequences used in this presentation, are based off of the MDT client task sequence template, but modified to include our customizations to address additional user data migration and recovery needs. Steps with names enclosed by asterisks are my way of indicating areas of the task sequence where customizations have been implemented. Let's go ahead and step through this task sequence and highlight key actions, starting with the Use Toolkit package step, which is a default MDT action. This step, among other things, establishes the deploy route variable, which is referenced throughout the task sequence. Deploy route is a variable that is used to store the full path to the MDT files package. MDT files is a package with the folder structure that contains all the MDT scripts, Windows Automated Installation Kit binaries, and other assets used by the MDT task sequences, so it is essential that the deploy root variable be established early in our task sequence. The gather step is another MDT default action. This step executes the ZTI gather script that performs an inventory of the system and creates additional task sequence variables for various hardware attributes. It's also the MDT script that processes the deployment logic included in our custom settings INI. This next action is an example of a script that I might use to define logic to set variables that would otherwise be too complex or impractical for custom settings INI or using the native task sequence functionality, or if I just wanted to minimize the number of steps in my task sequence. If we take a look at the actual script in this example, it's not particularly complex, but I am using it to set additional variables like the computer's OU, time zone, and language settings based on selections made in the front-end HTA or defined by collection or computer variables. Many of these variables could be set by default actions provided by the task sequence. For example, I could set the time zone using the Apply Windows Settings default step and the OU with the Apply Network Settings step. Now, I could have multiple Apply Windows Settings steps configured with different time zones and Apply Network Settings steps with different OUs defined and conditionally execute those based on a variable value. But in an effort to keep my task sequence as easy to manage and maintain as possible, I'm using this script to override those default actions, if necessary. For example, you only see one case in which I'm setting the time zone with the script. The default Apply Windows Settings action later in the task sequence defaults to the Eastern time zone. So I only need to override this variable value if the system I'm deploying will ultimately not reside within the Eastern time zone. Any variable explicitly set, like in this script, will take precedence over the value of that same variable if set by default task sequence actions, like for example, Apply Windows Settings. Because OSD and MDT sometimes use different variables to store scan state switches, this action, and the one just below it, ensure that these variables are in sync, so that whether the user state is captured with the native OSD functionality or with MDT scripts, the action taken with regards to capturing the user state will always be consistent. These steps also take the default list of scan state switches as they are defined in custom settings INI and appends to it an option that is only available to USMT version 4. Which generates a file that provides a simple list of all the files migrated during a capture. Because this switch is only available in USMT version 4 and custom settings INI is shared by all task sequences, including those that deploy Windows XP where we have to use USMT version 3 that does not recognize this switch, we did not include this option in custom settings INI, but instead we are appending it here in this task sequence that only deploys Windows 7 and only uses USMT version 4. You might have noticed a slight difference in the USMT options set between these two steps. One sets the level of logging detail with the /v switch while one does not. This is not an oversight, but is intentional to account for the differences in how this option is defined based on whether OSD is performing the user state capture or we are using MDT scripts. Moving on, this next group of steps performs an optional full system backup of the computer prior to deployment. I say optional because this group of steps is run dependent on conditions defined on the Options tab. The conditions require that the do backup variable be set to yes. Unless do backup is set to yes by our front-end HTA or elsewhere, like with a collection or computer variable, the computer will not be backed up. It also requires that the task sequence be running in Windows PE, which means that this backup series of steps is only applicable to the new computer and replace computer scenarios and automatically skipped for the refresh scenario. This particular group of steps uses MDT scripts to perform a full system backup of the computer. MDT's ZTI backup script, which captures drive images with image X, uses the value of the computer backup location variable to determine where to store the WIM archive it creates. Depending on the value set for computer backup location, MDT may attempt to store the WIM locally on the hard drive of the computer if there's enough free disk space, or to a state migration point. Because, as I mentioned earlier, OSD supports getting a path to the state migration point by executing the request state store action, and that this action has a built-in condition that prevents it from running within Windows PE, and because we want to enable system backups for all scenarios and to have a consistent location to which our WIM archives are stored, we are going to have MDT instead always copy our backup WIMs to a UNC path. The path of this UNC is determined by the backup share variable that we have defined per location in our custom settings INI and MDT database. Also, if you'll recall, in our custom settings INI, we have the value of the computer backup location variable set to network, which means that MDT will never try to store WIMs locally. Because the ZTI backup script assumes conditions that will not be true for our custom deployment, given that we always want our backup WIMs copied to a server share, this step captures and stores the value of the deployment method variable that is evaluated by ZTI backup. Subsequently, this step changes the value of the deployment method variable so that ZTI backup will build the path to the WIM image based on the MDT backup related variables. This step simply runs checkdisk and fixes any issues it finds prior to backup. In this example, I'm only checking for and fixing logical inconsistencies with the /F switch. However, you could have the switch specified as a variable and prompt to enable for a more thorough physical surface scan to be performed with the /R switch to recover data from bad sectors, but which would take significantly longer. This step runs unmodified ZTI backup as is. Once backup is complete and has encountered no errors, this step restores the original deployment method variable value as originally set so that we don't trip up MDT later on down the line. The USMT local variable is set and used by MDT's ZTI backup script and by its ZTI user state script, which captures and restores user states. Because we don't want our backup activity to influence any user state functionality later in the task sequence, this action simply gives USMT local an empty value. This next group of steps is a way of performing backups without the use of MDT. It's disabled here in this task sequence because I find it more advantageous to use MDT, but we will review it here nevertheless. In an attempt to emulate the MDT functionality as closely as possible, this first step defines a variable, which happens to have the same name of the variable that MDT uses for the same purpose, for the name of the folder to which to store the backup WIM. This step is used to set the name of the WIM file, again using the same variable as MDT. This step maps the network drive to a UNC path specified by the backup share variable. I would have to define the value of the backup share, likely using a script, HTA prompt, or collection or computer variable. The reason I'm mapping a drive to the UNC path is so that I can encrypt the credentials. This is not entirely necessary, however, since I could always grant share permissions to the ConfigMgr client network access account. This step executes the architecture-specific version of image X to capture an image of the C drive to the specified path and file name. This example happens to use the MDT files package, which already has all the required binaries from the Windows Automated Installation Kit available, but I could have just as easily made my own package using the wake as the source. If we look at the conditions on this step, we can see that it will only run if a C drive exists. We can use this same logic to back up other drives as well. Just as we had to synchronize the OSD and MDT variables for scan state, this step does the same for load state, again getting the base set of arguments from custom settings INI. This group of steps does as it suggests, captures the user state offline, but only conditionally. The user state will be captured offline by these steps only if our custom offline state capture variable is set to yes, which, you'll recall, we are setting in our front-end HTA with the checkbox option, and only if the task sequence is running in Windows PE, which again if we're still in PE at this stage of the task sequence, means that we are performing the new computer or replace scenarios. Again, we have another step to run check disk, but this time we are only doing so if it has not already been run. When ScanState is run in offline mode, it has no idea where Windows is installed, so we need to provide it with the path to Windows using the offline WinDir switch. This step sets a custom variable to store the value for the offline WinDir parameter. This step sets the Windows directory to d:\Windows if it exists. The reason why we are setting it to d:\Windows is because drive letters sometimes change when a system is booted into Windows PE. This next step sets the path to the Windows directory to its more likely location, on the C drive, but again, this is also based on a condition. If c:\Windows exists, this step will override the value of the custom OSD WinPE WinDir variable set by the previous step, which set it to d:\Windows. This is just an example of one way to address the issue of providing ScanState the path to Windows when drive letter assignments may change or the folder to which Windows is installed is not the default. Perhaps a better alternative to setting the value of the OSD WinPE WinDir variable conditionally by the task sequence for ScanState's offline WinDir switch is to instead use ScanState's offline switch, in which you specify an XML file, an example of which is shown here, that includes the path that you want ScanState to look for a Windows installation offline. This way, if ScanState finds more than one Windows installation, you can have it quit and have the task sequence fail. This step addresses an issue with USMT version 4 where the path to down-level manifests is not seen by ScanState. For more details about this issue, see Knowledge Base article 201-8593. This particular step is part of a group of steps that captures the user state offline using MDT's ZTI user state script. While ZTI user state addresses this particular issue when it's run from within Windows, in other words, when it captures a user state online, it does not do so when it's run from within Windows PE. So this simple batch file resolves this issue. This batch file is stored in the parent source folder of the USMT version 4 package and accepts two parameters. The first parameter is used to delete any existing hard link migration store on the drive prior to capturing the user state. The second is used to copy the USMT manifests to the system's working directory, which is the Windows directory in Windows PE, but Windows System 32 for a standard version of Windows. This next step captures the user state offline using MDT's ZTI user state script. ZTI user state will automatically append the hard link and no compress parameters to the ScanState command that is run if the package referenced in this step is for USMT version 4. It also sets the USMT local variable to true. Because we would have just captured the user state offline using hard links in the previous step, we also need to update the OSD-specific OSD migrate additional restore options variable that is used by the restore user state action later in the task sequence so that it knows that the migration store is hard linked and uncompressed. This next group of steps is a way to enable offline user state capture without the use of MDT. This first step establishes the local path to where the migration store will reside. Again, you see here in these next two steps where we are determining the path to the offline Windows directory. Here we are constructing our full set of command line switches for ScanState, including a file to log its progress and our migration rule files. UDI-offline.xml is a migration rule file borrowed from MDT's UDI to capture additional settings that might otherwise be missed during an offline state capture. We are running ScanState with the command script so that we can also run other preparatory actions. This batch file is again included in the source folder for USMT and accepts a number of parameters. The first parameter used in this sample script is for specifying the drive in which to run check disk. The second is used for deleting any existing hard link migration store. USMT needs to know the architecture, 32 or 64-bit, of the Windows version it's performing an offline migration for. It'll do its best at determining this automatically. In fact, I've never seen it fail. However, if you'd like to ensure that it never gets it wrong, you could do so by specifying either 32 or 64 for the value of its MIG offline platform arc parameter. This is what the third parameter to this command script is used for. The fourth parameter specifies the path to the Windows installation by setting the value for the offline WinDir parameter. The fifth argument is referenced a number of times in this batch script. The first is to specify the path to a temporary scratch directory used by USMT, which requires at least 250 megabytes. And again to copy USMT binaries and manifests locally. Then to create a folder for the hard link migration store. And then finally to build the path from which scanstate is run. And the sixth and last parameter is used to pass in the majority of our scanstate arguments. This next step sets the USMT local variable to true, like MDT does, as a flag to indicate how the user state was captured so that we can later determine how to restore it. Again, we need to update the OSD specific variable used when restoring the user state to indicate that it was captured to an uncompressed hard link store. I'd like to pause here for a moment to relate that the general idea and strategy behind the backup functionality we've enabled thus far in the task sequence is that it would be turned on for a deployment automatically using either MDT computer-specific rules in custom settings INI or the MDT database by collection or computer variables, or on a one-off basis using the front-end HTA. Whereas the offline user state functionality would be enabled only manually using the HTA. The reason for this is that so far we've only enabled offline user state capture for the new computer scenario, and its use from a practical perspective requires that the person interacting with the deployment using the HTA know up front if there's a user state to be captured, and if there is, should it be preserved. So here's our first format and partition disk step in the task sequence. I say first because there's another further down in the task sequence which MDT includes in its client task sequence template. Why is there more than one? Well, based on the conditions of each of these steps, only one will ever get executed on a system per deployment. Before we look at the conditions of this step, I would like to point out here that all the actions we've reviewed thus far have occurred before we've done anything destructive to the system, like repartitioning and formatting the drives. So thus far we've been successful in implementing customizations to meet our objectives to extend user data migration and recovery scenarios. Okay, let's examine the conditions on this particular format and partition disk step, which will only run during the new computer scenario, which includes a system we're migrating to during the replace scenario. Translating this, the first set of conditions basically read that this step will only run if the advertisement for the task sequence is configured to download content locally when needed by the running task sequence. The task sequence is currently running in Windows PE and not from pre-staged media, and not if our custom offline state capture variable was explicitly set to yes by our HTA. The second set of conditions stipulate that the task sequence must be running in WinPE from standalone task sequence media, and again the offline state capture variable is not set to yes. The reason why MDT has this format and partition disk step is that if we're going to use download on demand for the advertisement, then we need to have a formatted partition to stage this content immediately to. The same goes for standalone task sequence media. I've added our custom offline state capture variable here to prevent the disk from getting wiped so that we won't lose our user state that is kept locally, since it's assumed that if you check the box in the HTA to capture the user state offline, then you know there's a partition defined that contains a Windows installation and there's a user state there you care to preserve, in which case there should be no need to format and partition disks. So, you'll want to consider carefully when you check this option in the HTA. Otherwise, if the option is checked and the system does not have a formatted partition, then this deployment may fail if it also meets the other conditions defined for this step. This also means that offline state capture is not possible using a hard link migration store or otherwise kept local on the disk when the advertisement is configured for download and execute, is multicasted, or deployed from standalone task sequence media. If you need to support offline user state capture for those scenarios, you'll need to implement support for copying the user state off to another disk attached to the system or to a server share. Also, if the drive is protected by full disk encryption, like with BitLocker, then you'll need to prompt or acquire from Active Directory recovery key information to suspend the drive protection or decrypt the drive. Even though we're not formatting and partitioning the disk when we've enabled offline state capture, it does not mean that the partition to which Windows will be installed won't still get wiped of all data, except for those protected areas like the path where we're storing our user state locally. And just because we've enabled offline user state capture for the new computer scenario here does not mean that we cannot repartition and reformat partitions other than the partition in which we're storing the user state. This may require a custom diskpart script, but given that diskpart can shrink and extend volumes, it's not likely you're going to be limited by enabling this functionality. Also, bear in mind that we've enabled the option to fully back up the system and gotten that backup file up off the disk and onto a server share should anything go wrong. While on the topic of backups and the functionality we've just introduced, one potentially convenient way of defining the path to the server share used for storing WIM image backups is to leverage the SMSDP variable that MDT establishes. This variable expands to the path of the distribution point, so if the DP has sufficient disk space for storing WIM image backups, then you wouldn't have to create location-specific rules for defining this path. You might instead let ConfigMgr do all the work of finding the nearest server. The next action I'd like to review here is this restart computer step that I've added. I've done this to address an issue that primarily occurs when booting from USB flash drives, but I've also seen it when booting from alternative sources like an integrated lights out board. Issues can arise because drive letter assignments change after partitions are created. This step simply forces the computer to reboot so that later task sequence actions do not get confused about where to read data from and where to write it to. The conditions on this step are identical to those for the format and partition disk step above, except that we've added an extra condition so that it only runs if the system is booted from USB flash media by evaluating the read-only SMSTS launch mode variable. UFD stands for USB flash drive. This step implements a fix detailed in Knowledge Base Article 977203. Running ccmcertfix.exe included with the hotfix requires that the ConfigMgr client hotfix for this KB be installed already on the system in which this task sequence is run. The determine local or remote user state step runs the ZTI user state script provided by MDT, which is configured to run in the state capture phase, which only executes during the refresh scenario. Because this task sequence will be used to deploy Windows 7 and will be using USMT version 4, this script is used to set the hard link and no compress switches for scan state and load state. ZTI user state will also automatically define the path to the Windows folder for scan state's offline window switch and other USMT environment variables specific to offline user state capture, like the MIG offline platform arc variable that specifies the architecture of the version of Windows from which the user state is being migrated. We covered these USMT variables during our review of the batch file we could use as an alternative to ZTI user state to capture the user state offline for the new computer scenario. This script also creates a variable with the name USMT local and sets its value to true. As mentioned previously, USMT local is a variable that will be evaluated later in the task sequence to determine how to restore the user state. Here's our other format and partition disk step. The conditions on this step mean that we'll partition and format if we're not executing the refresh scenario and if the previous format and partition disk step did not run. This instance of the format and partition disk step is run if the advertisement is not configured to download content as needed by the task sequence, we're not deploying from standalone or OEM pre-staged media, and again, our custom offline state capture variable is not explicitly set to yes. Again, we're forcing a reboot after partitioning if we're deploying from USB media. So the conditions are similar to those for the format and partition disk step above it. Here's our second backup group of steps. As you'll recall, the first backup group we discussed earlier in the task sequence was used only for the new computer scenario, whereas this group is only executed during the refresh scenario, but only if the do backup variable is set to yes. This series of steps is very similar. The only difference is that this time we want to capture and later restore the value of the USMT local variable that would have been originally set by the determine local or remote user state step that runs the ZTI user state script. MDT's ZTI user state and ZTI backup scripts both evaluate and can set the value of the USMT local variable, which is used for determining whether to store the user state and WIM backup local on the hard drive or to a remote server. As was related previously, we want the user state store location to be dynamic based on which version of USMT we can use, disk space available locally, and the deployment scenario performed. Yet, we want the WIM image archive always moved to a predefined share we've established just for this purpose. Since, with our deployment rules, the location of the WIM image backup file is going to be consistent, we don't want ZTI backup to change the value of the USMT local variable. So if it does, we want to reset it back to the value originally set by the determined local or remote user state step. This is accomplished within this series of steps. Here's our second perform offline user state migration group of steps, but this time it supports the refresh scenario. The only difference between this group and the group we reviewed earlier, which was to support the new computer scenario, is that this time we don't need to figure out what folder Windows was installed from which to capture the user state. We can rely on MDT's determine local or remote user state step that ran previously and set the value of the OSD WinPE variable to the path of the Windows folder, which was determined when the old instance of Windows was still running. If you recall, we previously reviewed a group of steps that could be used as an alternative to MDT for capturing the user state offline during the new computer scenario. If you choose not to use MDT for capturing the user state offline as demonstrated here, then you could copy those same steps and paste here to support offline user state capture for the refresh scenario as well. Here's a quick tip I'd like to share to address an issue I've had to work around before. If you're deploying systems in an environment where clients should be locating and registering with a key management service server but are failing to do so, thus causing the whole deployment to fail, you may find that entering in a generic KMS key here for this step in the task sequence should allow the deployment to finish and succeed, after which the deployed system is then able to successfully register with KMS automatically during a subsequent attempt once fully deployed. The Setup Windows and Config Manager step allows you to specify installation properties for the Config Manager client. At a minimum, I would recommend that a fallback service point be specified to capture client installation and assignment failures, and a server locator point when deploying systems that will be assigned to workgroups or that reside in remote AD forests or otherwise unable to read Active Directory for client assignment information. This step also provides a convenient way of installing Config Manager post-service pack client hotfixes. Unfortunately, the dialog box for specifying these hotfixes is limited in the number of characters it can hold. This can be a problem, for example, when you want to install all of the post-Service Pack 2 client hotfixes because the string that contains the paths to these hotfixes can overflow this installation property dialog. A possible workaround is to do what I've done here, which is to create a custom variable whose value is the string for the patch client installation property containing the paths to each of the hotfixes. A variable's value can be up to 4,000 characters in length. Back to the Setup Windows and Config Manager step, I then refer to that custom variable. Transitioning now into the state restore phase, the first action I'd like to review is the step that installs software updates. I'm borrowing what I consider to be a good practice from MDT Light Touch. That is, to install software updates twice in a task sequence. The first of these patches the operating system or potentially anything else in the base image like applications, and can also install common dependency components like the .NET framework. Also, because of a hard-coded timeout ConfigMgr imposes during software update installation, which is documented in Knowledge Base Article 2009754, not all updates may get installed during the initial pass. After the base image has been patched, we begin installing software with the install software task sequence actions. This particular install software action installs multiple packages based on rules in custom settings INI and will be used to automatically reinstall software based on the inventory reported by the ConfigMgr client previously installed on the system or by association with another system as defined in the ConfigMgr console. We'll come back to this topic later and discuss how we enable this at the back end. But for now, just keep in mind that we do have an install software action in our task sequence to install multiple packages that reference the base variable with the package's prefix, which is the base variable name that MDT uses to install packages based on deployment rules in custom settings INI. This next step installs software packages that were manually selected from the front-end HTA. The strategy and implementation of this functionality has been discussed and demonstrated in a previous presentation. Once all software has been installed, it's then time to scan the system again and apply any updates that have become applicable after introducing additional software to the system. Only after all software has been installed is the recommended time to restore the user state. If we're performing the replace scenario, then we need to execute the request state store action that will return a path and set the value of the OSD state store path variable that will be used to determine where the user state must be restored from. We only need to run this action, however, if the user state was not captured offline and stored local on the system as indicated by the value of the USMT local variable. We have two restore user state actions here in this task sequence, but each has a unique set of conditions such that only one of the two will ever run per deployment. The primary reason we have more than one is that we have a different set of migration rule files that should be used by load state depending on whether or not the user state was captured offline to a hard link migration store or online to a state migration point. This first restore user state step supports restoring the user state from an offline migration store, which, for this task sequence, will be the case when performing the new computer or refresh scenarios. Clicking the Files button to display the migration rule files, you can see in this example we're including the UDI offline.xml migration rule file for load state since the user state was captured offline. The conditions on this step mean that we'll only attempt to restore the user state from an offline migration store if the path to the state store has been set and the USMT local variable is set to true, which is our flag in this task sequence that only references USMT version 4 to indicate that the user state was captured offline. However, if the user state was captured online, which is the case when restoring the user state during the replace scenario, we support that with the second restore user state step. The set of migration rule files for this scenario do not require the use of UDI offline.xml since the user state was not captured offline, so in this example we're just sticking with the default. The conditions on this step mean that we'll only attempt to restore the user state from the state migration point if the request state store action we ran previously provided us with a valid path to the user state and if the USMT local variable is not set to true. Finally, we can release our session to the state migration point by running the release state store action, which is only necessary during the replace scenario. So that concludes our review of a task sequence that can be used to deploy Windows 7 and that implements customizations to enhance our user data migration capabilities. Next, I'd like to quickly review our task sequences used to deploy Windows Vista and XP, but this time we will only focus on where these two task sequences differ from the task sequence we just reviewed to address the unique characteristics of each of those OS deployments. We'll then also briefly review the three task sequences that are used primarily to capture the user state from the old system during the replace scenario. Here's our task sequence to deploy Windows Vista. The primary difference between this task sequence and the one we reviewed to deploy Windows 7 is that this task sequence has a group of steps to capture the user state online during the refresh scenario. This task sequence does support capturing the user state offline as well for the refresh scenario, just as we did previously, but only when the operating system running is not Windows Vista. However, if the OS we're migrating from is Vista, then ideally we want to take advantage of ScanState's target Vista switch for reasons previously related. The conditions on this group of steps mean that they'll only run if the system on which the task sequence is executed is currently running Windows Vista. So in other words, we'll be migrating the user state from Windows Vista to Windows Vista. This step here appends to the list of ScanState parameters the target Vista switch. Again, just because we're capturing the user state online does not mean that we cannot leverage a hard link migration store. The determine local or remote user state step that runs prior to this group of steps should activate the hard link and no compress switches for ScanState. We're also setting a flag here with our online state capture custom variable to indicate that the user state was captured online so that we don't later attempt to capture it again offline. This offline state capture group of steps for the refresh scenario, and here primarily to support user state migration from Windows XP, only runs if our custom online state capture variable is not set to yes, indicating that the user state has not already been captured online. Further down in the task sequence where we restore the user state, we now need to evaluate the value of the online state capture variable for both restore user state actions. Just as we needed to for Windows 7, we need to know which set of migration rule files to include for load state depending on how the user state was captured. Here now we're looking at our task sequence that deploys Windows XP, where we can only use USMT version 3. So our ability for expanding user data migration options are more limited, so you'll not find any reference to offline user state migration in this task sequence. You do see, however, that we've enabled full system backups for more than just the refresh scenario, have included ScanState optimizations for Windows XP, and added some other XP specific enhancements. Let's now take a quick look at our task sequences used during the replace scenario and that are run on the old computer. This first task sequence is utilized on the old system when the user state is being migrated to a Windows 7 system. In this example, I've incorporated some of the actions provided by the P2V migration for Software Assurance Solution Accelerator that can capture the current OS image into a VHD using sysinternal's disk-to-VHD tool. I've added some conditions to these steps so that they only run when appropriate. Since user state migration always occurs online during the replace scenario, I've enabled volume shadow copy support for the capture process. I'm also running our script that we reviewed earlier to copy the USMT manifests locally to the system's working directory so that they'll be found by ScanState. And because we want our backups enabled conditionally to always be moved off disk to a remote server, and we want our server share to be consistent for all scenarios in which we do backups, I've added our same group of backup steps as we're using in our other task sequences. Our task sequence for the replace scenario that migrates the user state from the old computer to a Windows Vista system is nearly identical to that which we used for Windows 7. The only difference is in this task sequence we've added a step to conditionally enable the target Vista switch for ScanState. The same is true for the task sequence used during the replace scenario when migrating to Windows XP. The only differences are that this time we are enabling the target XP switch and referencing USMT version 3. The last topic on our agenda is to review the functionality that MDT provides for reinstalling applications on a system that it determined were previously installed on that same system. This is accomplished by executing a stored procedure that performs a lookup against the ConfigMgr site database for applications previously installed on the system based on the add remove programs list from hardware inventory associated with a MAC address owned by that system. If any records from add remove programs inventory are found, they are then matched against another custom table that is manually set up and maintained that determines which of these previously installed applications should be reinstalled, and if so, if they should be replaced by a newer version of the same application. This functionality is detailed in the MDT samples guide shown here. This feature, as implemented in the samples guide, only supports the new computer and refresh scenarios. It does not support the replace scenario. So, if we wish to extend this functionality to the replace scenario as well, then we need to modify the stored procedure as it is provided in the samples guide. We'll also want to modify the stored procedure to account for 64-bit applications because the SQL view that is used in the guide does not include programs inventoried from the 64-bit registry. MDT refers to this automatic reinstallation of packages based on inventory as dynamic package installation, and enabling it starts with creating a database from the MDT deployment workbench by completing the new database wizard. We then need to include a section in our custom settings INI to enable the lookup of packages to reinstall based on the MAC address of the computer we are deploying. To enable an application to be reinstalled automatically, we manually create records in the MDT database's package mapping table. The package mapping table associates an application's add remove programs entry with the ConfigMgr package ID and program name combination. The application's add remove programs identifier in the table is not necessarily the name of the application as you would see it in add remove programs in Control Panel. Instead, MDT uses the product ID of the application that is retrieved from add remove programs registry entries returned by hardware inventory. You can execute a query like this one against the ConfigMgr site database to retrieve the product ID for a particular application registered in add remove programs. The final step is to update the stored procedure that we use so that it evaluates both 32 and 64-bit applications, and so that it also supports the replace scenario where we may want a subset of the applications that were installed on the old computer automatically installed on the new computer. This is a view of the updated stored procedure. The changes made are that I've replaced the SQL view for add remove programs and included logic to retrieve programs inventoried from the old computer that's been associated with the new computer for the replace scenario. I'd like to conclude this presentation by sharing a few knowledge base articles and links to other helpful resources.